All right, I think we're functional. Okay, so yesterday we practiced finding the critical values with the t-distribution, and we looked a little with rejection regions to figure out, based on a t-value that we get from a sample, would it be rejected or not rejected. We will be comparing a t-value from our critical values on our chart to a t-value that we calculate. We have seen this formula before. This is review. This is actually the same formula we've been using for the z-scores. The only difference, remember, with a t is that it's not the population standard deviation here, it's the sample standard deviation here. But everything else is the same. So you're going to do the mean of your sample minus the mean that we're testing for, whatever that is. It's part of our hypothesis. And then the sample standard deviation divided by the square root of n. All right. So I put the steps on your paper here if you need to walk through them. Again, these are pretty much the same as what we were using with the z-testing. We're going to verify, first of all, that we either know or don't know the population standard deviation, and that tells me to use z or t. We also want to make sure that we're either normally distributed or greater than or equal to 30 for our sample size. We're going to write the null and the alternative hypothesis, probably be given the level of significance. If it's a t-test, you're going to have to find the degrees of freedom and use that to find on your t-distribution chart those critical value or values, depending on if it's left tail, right tail, or two tail. Then we're going to calculate t, see if it's in our rejection region, and then either reject or not reject and summarize. All right, so let's try this one. A used car dealer says that the mean price of used cars sold in the last 12 months is at least $21,000. You suspect this claim is incorrect and find that a random sample of 14 used cars sold in the last 12 months has a mean of $19,189 and a standard deviation of 2,950. Is there enough evidence to reject the dealer's claim at a level of significance of 0.05? Assume the population is normally distributed. Okay, so checking a couple things first. Number one, do I have a sample size bigger than 30, or is it normally distributed? We are normally distributed, so we check that box. Second thing I check is my standard deviation. Is it a population standard deviation or a sample standard deviation? It is a sample. So S instead of a mu is 2,950. And that's telling me immediately that I know I'm going to use my t distribution, not my standard normal distribution, my z chart. Okay, let's see what else we've got here. What's my n? 14. What's my x bar, my sample mean? Level of significance we were given, 0.05. Let's go ahead and write our claim, our null, and an alternative, starting with the claim. So a used car dealer says the mean price of used cars sold in the last 12 months is at least $21,000. So if we see at least, greater than, less than, equal to, what do we got? What does that mean? It's greater than or equal to if it's at least 21,000. And because it's greater than or equal to, is that my null or my alternative? It is the null because it's got the statement of equality. What's the alternative then? Less than 21,000. Okay, let's go ahead and calculate t from our statistics, and then we'll get the critical values in a minute. All right, so t, same formula as before, it's just not a population standard deviation. So x bar, 19,189, minus the mu that's being tested for the population mean, 21,000, divided by your standard deviation, 2,950, over the square root of your sample size, 14. And we can do 2 decimal places on this, would be fine. And I get negative 2 point, if I give it 2 decimal places, it's 296. So I would say negative 2.30 is our t value. Okay. All right. Critical values. Is this a left tail, right tail, or two-tail test? You look at your alternative hypothesis, yep, and it is left tail because it's less than. Okay. We also need our degrees of freedom. Degrees of freedom are n minus 1. If our n is 13, our degrees of 14, our degrees of freedom are 13. And that should give you enough then to find your critical value on your chart. Remember, if it is a left tail, whatever number you get in here, you're going to put a negative in front of it because it's on the left side of our mean when we look at that distribution. All right, so on your t-distribution, across the top, you're going to look at one tail. Then you're going to go over to your level of significance, 0.05 for this one, so that would be in the second column. And then you're going to go down to 13 degrees of freedom. So I see 1.771. Look good? All right, so my t sub 0, we're going to put a negative in front of that because it's a left tail, negative 1.771. Good? All right, so now little sketch of this. Whenever you're doing rejection regions, like on a test, you're probably going to have to sketch this, so it's a good practice to get in the habit of that. Let's draw that critical value somewhere over here, negative 1.771. And now I want to compare that to the t value that we found. Would negative 2.3 be in that rejection region? It would be in the rejection region. Yes. So if it's in the rejection region, what do? We reject. All right, so then I want to summarize this. So my summary is made up of two different pieces of information. Number one, is there enough evidence or not enough evidence? There is enough. If you are rejecting, that's what you want to happen. So there's enough evidence to either reject or support. In this case, because the null hypothesis was the claim, we're going to say there is enough evidence to reject the claim that the mean price of used cars sold in the last 12 months is at least $21,000. Okay? Good? All right. So since this is so similar to what we've done before, I think you guys can do the last two on your own, maybe, hopefully. All right. So try it. I'm pretty sure I had it set up so one of those is right tail, one is two tail. If I was planning right, that should happen. We'll see. Okay, go ahead and try them with your groups. And then at the end, I'll probably have you guys put some pieces and parts of this up on the board and we'll talk about it, make sure everybody's good. All right, we all have that answer. Now let's see the next one here. All right, there we go. Or the spinner. You want spinner today? All right.